Welcome in, everyone. We're going to be doing some GRE math, and we're going to be doing some arithmetic tonight. So it's like real fundamental math that we're going to be practicing. So happy, Monday? Happy Monday, everyone. So the number one says, is 6.205 greater than 6.250? So how you need to look at this problem, see how the sixes are the same? So we're looking at, is $205 greater than $250? That's how you want to look at this. Is 205 greater than 250? No. So this decimal is not greater. This sign means greater. Greater than. Okay, so no, first one's no. Number two says, does 6 times 12 times 8 equal 6 plus 12 times 8? So, one way to show that this does or does not equal is to actually do them out. So we would first start by doing 6 times 12. So, because we always start within the parenthesis. And so 2 times 6 is 12, carry the 1. And then 6 times 1 is 6, plus 1 is 72. And then we would times that by 8. Okay, we're trying to see if it is equal to 6 plus 12 times 8. Okay, so let's do 12 times 8. Let's see what that gives us. So 8 times 2 is 16, carry the 1. And then 8 times 1 is 8, plus 1 is 96. We still have this plus 6 over here. Okay, so 72 times 8. We're asking, does that equal 6 plus 96? So you could stop here really and say no, but we'll go out. We'll go all the way. So we're going to show 72 times 8. 8 times 2 is 16, carry the 1. And then 8 times 7 is 56, plus 1 is 57. And we're questioning, does 576 equal 96 plus 6? 6 plus 6 is 12. And then 9 plus 1 is 10, so that's 102. Do they equal each other? No. And then that's how we would show that. Good. So I see Jeff. Hey, welcome in. Welcome in, Jeff. Alrighty, number 3. Evaluate and write as a mixed number. All right. So whenever you have a addition and subtraction, we always want to work from left to right, you guys. So we would start with the subtraction. But in order for you to subtract fractions, you have to have the same denominator. Thank you for those double taps. I appreciate it. So what we're going to have to do is we're going to multiply this by 3. Now, let me explain why we're multiplying this by 3. We want them to be the same bottom. So we want them both to be 21. Because that's called the greatest common factor, or the least common denominator, actually, not the factor. Least common denominator. And so 7 times 3 is 21. And then 2 times 3 is 6. And then we'll just leave this the same. And now that we have the same denominator, we can minus our numerators. So our tops, okay? Whenever I say numerator, that means tops. So 6 minus 3 is 3 over 21. And now we can add that to 2 and 4/14. All right, now, since it wants us to write it as a mixed number, right? We need to have the same common denominator here. Can anybody tell me in the chat what 21 and 14 both go into? And anybody in the chat? 7, 7. Okay, so yes, you guys are saying the what are you guys saying? You guys are saying the greatest common factor, but what we need is the LCD. Good. David said 42, 42. Yes, because we want, what do both 21 and 14 go into? Good. So people said 42. They both will go into 42. So let's figure out how, right? So 21 times 2, if we times that by 2, we get 42. And then 14 times 3 will give us 42. So whatever we do to the bottom, we have to do to the top. So 2 times 3 will give us 6. And then 4 times 3 will give us 12. And so we could carry this. Now what we can do, since we have the same denominator, we can add our numerators here. So 6 plus 12, okay, we can carry the big 2 over. And then we know we're having 42. And 6 plus 12 gives us, what is that, 18? Okay. We can reduce this. They both have a 2 in common. Do they have something higher, you guys? I think just a 2, maybe a 6, huh? Yeah, 6 actually. Because we could say this is, I'm gonna write it up. I'm gonna write it right here. Can you guys still see if I write it right here? 18 divided by 6 is 3. And then 42 divided by 6, 6 times 7 gives us 42. So that's 7. And this is our answer as a mixed number. So some people may have wanted to change this to an improper, which you're not wrong, but then you would have had to do more steps by dividing that improper back into a mixed number and then getting this. So whenever they say write your answer as a mixed number, you guys, I think this is the best way with least steps. Okay, TT said I still don't get it. Okay, TT, where did I lose you at? Where did you get lost? Yep, would you have made it improper? Who? I mean, what, I wouldn't have made it improper because they were asking for it to be mixed. What's improper mean? Improper means when, okay, let me show you. So to change this to improper, it's saying the numerator, the top number is bigger than the denominator. So let me tell you what some people might have done. They would have done, to change this to an improper fraction, they would have said multiply, then add. So they would have did 14 times 2, and then they would have added the 4. And they would divide that by what they're dividing by is 14. So if we do 14 times 2 plus 4, I'm going to take out the calculator. So 14 times 2 plus 4 gives us 32. And we would have got 32 over 14. So this is called an improper because the top number's bigger than the denominator. Great question. Is 2, 12, 14 improper? No, that's not. This is not improper because the numerator, this is a mixed number, but whenever the numerator is smaller than the denominator, it's called a proper fraction, not improper. Great questions, you guys. Then reduce 14, then reduce 32 over 14. Yes, we could do that and then add it here. But yeah, we could do that. But does this make sense, you guys? Does this way make sense? So we took this step out of it because then there would have been more steps. Yes? Okay, perfect. All right, let's keep it pushing. Okay. So we have some more basic questions. Okay, this is the basic level. We're going to get into intermediate and then advanced, okay? Learning coding and need to refresh my math skills. So this is helpful in general to get my gears turning. Oh, wonderful. Bless your heart. I took one computer programming class and I was like, not for me, because all math majors, or at least at Sac State where I graduated from, they all had to take a computer programming class. I took C++ programming, C+ programming. I was like, bless your heart. If you get it, bless your heart, okay? So convert 17/4 to a mixed number. All right, so we have an improper fraction. So that means the numerator is bigger than the denominator. And how we change this improper fraction to a mixed number is we divide it. So we ask ourselves how many 4s can fit into 17. And we're going to say 4. 4 times 4 gives us 16. We can subtract. 17 minus 16 is 1. So this is our remainder. How we write this as a mixed number, this is our whole number here. And then our remainder goes on our numerator, and what we divide by goes as the denominator. And so this 4 1/4. Oh, you're so welcome, Mary. And congrats on going back. Love it. All right, let's do number 2, you guys. Reduce 6/42 to its simplest terms. So if we want to reduce this, remember there's multiple ways to reduce it. Thank you, the muffin, for the heart. Heart puff. Thank you, thank you. So if we want to reduce this, good. Asia said 1/7. Kevin said 1/7. Good. So what did you guys divide out? Perfect. Becca says 1/7. For the people that don't get it, what did you guys take out? 6. Beautiful. So we can divide this by 6 and divide this by 6. And if we do that, we get 1/7, which is perfect. Good. All right. Simplify 3/5 times 3/8 times 2/3. All right. So, one way we could do this is just multiply straight across, right? But then we would always have to reduce to get to the simplest fraction. So what I always try to teach my students is look to see if you can cross cancel. So what do I mean by that? Well, we have 3/3. So 3/3 cancels because you could divide this by 3 and you could divide this by 3. And so they go to a 1. We also have a 2 and an 8 that can go into each other. So if we divide this by 2 and divide this by 2, 2 divided by 2 will give us 1. And 8 divided by 2 is 4. So we would have 3 times 1 for our numerator. And then we will have 5 times 4, which is 20. And that is how we cross simplify, cross cancel. Thank you for all the follows, you guys. That was easy. Haven't done math work. Good. I'm glad it was easy. Okay, let's keep it going. Remember, this is the basic level. Okay, so we're just warming up our gears. And then we're going to take it up a little notch when we get to intermediate. And then advanced is going to blow our minds. So we have 1/3 plus 1/5. Okay, whenever you add fractions, you have to have the same bottom. Can you guys put in the chat, what is going to be our denominator? What's going to be our LCD? Oh, you're so welcome, Livy. 15. Good. I see those 15s coming in. Beautiful. So if we put 15 here, and we put 15 here, then we have to go back up and we have to ask ourselves, 3 times what will get us 15. Well, 5. But what we do to the bottom, we have to do to the top. And then 5 times 3, same thing. So then we can do 5 times 1 is 5. 3 times 1 is 3. And now that we have the same denominator, remember your denominator stays the same and you add the tops. So 5 plus 3 is 8. And an even over an odd, they won't have anything in common. So that is our answer. Good, Sage. Yes. All righty. So we have 8.84 divided by 5.2. This is where it gets a little, I don't think you can, I'm not sure if you can use a calculator on the GRE or if you can only use it on certain parts. Thank you, the muffin, for the dinosaurs. Thank you, thank you. So let's just do it without a calculator, okay? Just in case some people can't use the calculator for this part. So remember, you can't divide by a decimal, okay? So what we would have to do is make this a whole number. And how we would make this a whole number is we would move this decimal one place to the right. So what we do to the outside, we also have to do to the inside. So this decimal would move right here. So we could rewrite this as 52 into 88.4. Okay. Good, Kevin. Yes. So if we put it right here, we're going to put it up here. Then we're going to ask ourselves, can 52 go into 8? No. Can 52 go into 88? And yes, but how many times? So we can only fit one 52 into 88. Okay, so we would do 1 times 52, then we will minus. And 8 minus 5 is 3. 8 minus 2 is 6. Okay, we drop down our 4. So now we have to ask ourselves, how many 52s can fit into 364? What do you guys say? How many 52s can fit into 364? Does any 7? Max says 7. So how I would look at this is, well, I know 50 plus 50 is going to get me 100. So if I'm trying to get into 300, then that's 50, 50, 50, 50, 50, because this will be 100, this will be 100, right? So I have 1, 2, 3, 4, 5, 6, and then oh, I forgot, I didn't see the name. But like someone said in the comments, they said 7. So if we do another 50, because another 50 can fit in that 60, so we would have 7. So then we would do 7 times 2 is 14, carry the 1. And then 7 times 5 is 35, plus 1 is 36. Yes. And then our answer would be 1.7. Shouldn't you be dropping that? Drop in what? What should we be dropping in? And this is minus the decimal. Oh, great question. No, the decimal only pertains to the top, never the bottom. Only when you're adding decimals or subtracting decimals does the decimal go down. That's a great question, IMJ. Yes. So let's do number 3. Yes. Oh, wow, you took AP Calc? Yes. I know it's always the basics, right? Because when you go so far, I'm telling you, when you go that far, it's like you never really remember like the basic stuff. It's like, wait, did I even learn this? But it's like, yes. So let's do this one. So so this is how I would, whenever I multiply decimals, you guys, I don't pay attention to the decimals. I only pay attention to the decimals when I'm adding or subtracting, or like if you have to divide, okay? I'm going to show you a trick that we're going to do. We're just going to do 267 times 408. Okay, that's what we're going to do first. So 8 times 7 is 56, I believe. And then 8 times 6 is 48. Plus 5, it'll be 53. Yep. And then 8 times 2 is 16. Plus 5 gives us 16 plus 4 is 20 plus 1 is 21. Okay, carry the 0. Put your placeholder because now we're moving over to the 10 spot. So 0 times 7 is 0. 0 times 6 is 0. 0 times 2 is 0. Now we're moving over to the 100 spot. So we need 2 placeholders. And then we do 4 times 7, which is 28. Change this to a 2. 4 times 6 gives us 24 plus 2 gives us 26. Change to a 2. And then 4 times 2 is 8 plus 2 is 10. So now we're going to add this down. So we get 6, 3, 8 plus 1 is 9, 6 plus 2 is 8, and we have our 10. Now this is where the importance of your denominators come into play, okay? Did I make a mistake? What did you say? 10.8936. Good. A to Z. Okay, perfect. So we have to count how many digits we have after the decimal. So we have 1, 2, 3, 4. So after every whole number is an imaginary decimal, okay? Is like a decimal point. So you would move this over 1, 2, 3, 4. And so our answer is going to be 10.8936. Whew. And that's how I will focus on multiplying decimals. Okay. Get rid of the dots. Just make them whole numbers. And then at the very end, count how many digits you have and then move it over. Okay. Any questions? Oh, you're so welcome, Ski. All right, let's do the intermediate. So now we're going to intermediate level and we're evaluating. So we're going to go here. I missed how you figured out the decimal part. Okay. So you're trying to, sorry. Okay, let me go back up. Okay, so you missed the decimal part. Okay, so the decimal part here, real quick, you count how many digits you have after the decimal. You have 4. And so after every whole number is a decimal, and then that's how many spaces you're going to move it to the left. And so that's how we would get the decimal here. Okay. All right. Let's keep it pushing, you guys. So we're at an intermediate level. Now we're going to evaluate 4/11 plus 11 over 12. We need to find our common denominator. Does anybody know what that is? You're so welcome, Sky. Thanks for joining me tonight. I know it's pretty late. I wanted to reach my goal. 142, 121. Thank you so much for the gift. Yes. So whenever you have this is called a prime number, you guys. A prime number is where only one times itself will get you that number. So this is a prime number. Whenever you have a prime number and like a composite number, you usually have to just multiply those together. So our LCD is going to be 121. Okay. So we will multiply this by 12. And then we will multiply this by 11. So 4 times 12 is going to give us 48. And then 11 times 11, this can't be right. It has to be, because 11 times 11 is 121. And then 12 times 11 has to be 132, I believe. Yeah, 132. Good. Okay, yeah, 132. And then we're going to add, thank you, you guys. Yeah, 132. Because we're multiplying these, okay? So now that we have the same denominator, remember that your denominator stays the same. And then we can add our numerators. So 121 plus 48. 8 plus 1 is 9. 4 plus 2 is 6. And then 169 over 132. Now, this is an improper fraction, right? Because our numerator is bigger than our denominator. And most times, sometimes they'll leave it like this, but they might want it as a mixed number. So let's give them both answers, okay? So let's do 132 into 169. So how many 132 can we fit into 169? Well, 1. And then we would subtract here. And then we would get 9 minus 2 is 7. And 6 minus 3 is 3. So remember how we write a mixed number is this is our whole. Our remainder goes as our numerator over our denominator, 132. And both of those are our answer. Okay, Kevin, what you confused on? Tell me what you're confused on. 1 and 37. Good, Alicia. Thank you for the shares, you guys. Thank you for the follows. Thank you for the double taps. Any questions? How did you get the 132? By doing 11 times 12. Am I wrong on my math? On my basic math? 11 times 12. Yeah, gets us 132. So we needed the same denominator in order to add fractions. And so I was explaining, if you have a prime and like a composite, you just have to multiply these two numbers to get your common denominator. Okay, so Kevin said, and divide by 4 12s. Let me see. Thank you, Sophia, for the rose. Oh, love it, Sharon. Sharon said, I just learned this today in my son's 4th grade math. Love it. Couldn't you just cancel the 11s? No, see, we don't want to cancel the 11s here. Because if we cancel the 11s, then that would defeat the whole purpose of us getting the same common denominator. And then I don't believe 169 can go into 11. Let me see. 169 divided by 11. Nah, see how it gets us a decimal? So both of these don't go into 11. So that's why we had to just divide it and change it to a mixed number. Does that make sense? No, I'm not sure. I know I've seen a little bit of this on the Praxis, but this is for the, GRE. Good. I'm glad you see where you went wrong. Yeah, Sophia, what are you guys learning in Algebra 1? Like, is it for final time? Or do you have like a special thing you want me to do? What are you guys working on in Algebra 1? All right, let's go to number 2, you guys. It's for a final exam. Okay, yes, that's what I was thinking about doing, is doing some Algebra 1 reviews and geometry reviews. Xander says, show us conversions, please. All right, okay. Well, so on these, because I post them on my YouTube page at Impact Math 19. So if you guys are looking for this recording, I always post all my lives over there. And I also do mini lessons over there as well. Like 5 problems explaining different concepts. So follow me over there on YouTube page if you want this recording. But I don't try to like mix up topics because some people go to my YouTube just for like this topic, if that makes sense. But I will add that on the to-do list, okay, Sophia? Especially the Algebra 1 review. So which operations will be evaluated third? Okay, so which operation will be evaluated third? And they give us this. So they're looking for PEMDAS, you guys. So where will we start first? We would start here with the exponent. So this would be our first thing. We would do 7 times 7, and we would get 49. Okay. Then we would have 4.02 minus 49. So this will be the second thing we do. So let's do that. So we're going to do 49 minus 4.02. See how there's remember the decimal after every whole number is after it. So we would have to borrow from this 9, make it an 8, then make this a 10, borrow from the 10, make it a 10. So 10 minus 2 would give us, can you guys see? Or am I off? Let me see. Can you guys see? So 10 minus 2 would give us 8. And then 9 minus 0 is 9. 8 minus 4 is 4. So this is 44. So then we would have 6 times 44 point. Is that right? Yeah, 44.98, but negative. Okay, don't forget that negative because it's $4.02 minus $49. So then we would have plus. We would have plus 5.15. So then what we would have to do next, so it's asking which operation would be evaluated third, is we would have to multiply before we can add. So to answer the question, the third operation would be multiply. So that's what our third operation would be. Okay. Yep. Multiplication. Good, Daryl. Yes. Multiplication. So that's our third one. Okay. Any questions on this? All right. Okay. Let's keep on going then. No questions? I have a course that has geometry, calculus, and statistics. Your TikTok is a lifesaver. Shared with my class. Thank you, Moonbeam. Thank you for sharing my content. I appreciate it. Especially now that, TikTok be paying its creators. So thank you. Every view counts. So true or false? 3 over 7 plus 10 equals 3 sevenths plus 3 tenths. What do you guys say? True or false? How did you get the 44? I got 44.98. Teacher's a little jealous, laughing out loud. Tell them don't be jealous, just join the live, come on. It's one math teacher supporting another math teacher, right? But this is how I got that 44.98. So we're subtracting $4.02 minus $49. So you have to write it like 49.00 minus the 4.02. And then we borrowed here. And then we subtracted down. And since when you go back here, since this number, this $4 is smaller than the negative 49, that's how come we come out with still a negative number. Great question. Great question. All right. So Kevin said false. I love it. Okay. So let's see. Okay. So this one over here is going to be 3. 7 plus 10 is going to be 17. Equals. Okay. Now remember when we add fractions here. See, this is different from this, you guys. See how this is underneath the same bar? So that's why we can do this 7 plus 10. Here, we have two separate bars. So we cannot just do 7 plus 10. We have to come up with the same common denominator. And since this is prime, we know that what we can do is just multiply these two numbers to come up with the denominator. So 7 times 10 is going to be 70. And then once you get that, you go back up here and you say, well, what can I multiply 7 by to get 70? I'm going to multiply it by 10. But what I do to the bottom, I also have to do to the top. Same thing here. 10 times what gives me 70? Well, 7 and 7. Okay. So 3 times 10 gives us 30, plus 3 times 7 gets us 21. And then once we have the same denominator, we keep the same denominator, but we add our numerators. So 30 plus 21 is going to be 51. And then 3/17. Now the question is, right now it's looking like false, right? But we have to ask ourselves, can we divide? Do they have anything in common? Can we simplify this? 51, 3 goes into it, but 3 doesn't go into 70. Does 7 go into 51? But then even if we divide this by 7, we're going to get a 10 down here and not a 17. So I don't believe. Can this be reduced, you guys? 51 over 70? No? I think you said no. No. Perry said no. No, no, no. Okay, perfect. So then, good. So Kevin, you were right. It is false. These are not equal. So the only way I could say, so we know it's false because even if we can divide by 7, let me see, 51 divided, oh, I keep on hitting times. 51 divided by 7, no, it don't. So good. And that is it. All right, so we're still at an intermediate level, okay? We're reaching the advanced level, okay? Where they can ask you some advanced questions. Sorry, I'm just looking at our problems. Okay. Do you have it? Do you do teas reviews? Yes, Ari, I do. I also have a teas playlist, and I have gone in the past. I have done teas lives, and so if you're looking for practice, like practice tests, you can find my past videos at Impact Math 19 on my YouTube page. Okay, if you're looking for like actual tests that we work through on the lives, you can go there, okay? T's test is for like nurses or healthcare administrators, people that are going into the like what is it? Respiratory therapists have to take it. Certain programs require that. Lynn, no. Unfortunately. I mean, I do the basic stats, but I do not do college stats. So evaluate 3 2/7 divided by 1/3. Okay. So what we have to do here is we need to change this to an improper. So we're going to multiply here and then add. So we're going to do 7 times 3. And we're going to add 2. And then you divide that by whatever you're dividing by, which is 7 in this case. And we're going to drop down divided by our 1/3. So 7 times 3 is 21. Plus 2. 21 plus 2 is 23 over 7. And then our division changes to multiplication. And then we flip this. So have you heard of keep, change, flip? So we keep this side the same. We change our division sign to multiplying. And we flip this fraction to its reciprocal, which is 3 over 1. Because we can never divide fractions, you guys. We can only multiply them, okay? That's why we have to do this keep, change, flip. And then I can't cross simplify, so I'm just going to multiply denominator with denominator, which is 7, and then numerator with numerator. So 23 times 3. Let's do that up here. 3 times 3 is 9, and then 3 times 2 is 6. So you get 69 over 7. Now, this is improper. They did start us off with a mixed number. So I would always say just change it to a mixed number. Let's get in the habit of knowing how to do that. So 7 into 69. So how many 7s can fit into 69? What do you guys say in the chat? Good. I see those answers coming in. Beautiful, you guys. I see the 69. Beautiful. 9, 9, 6. Oh, Moon said 9 and 6/7. I love it. So we have 9 here. And 9 times 7 is 63. And then 9 minus 3 is 6. So we're going to make this 9 and 6 over 7. And that is our answer. 9 and 6/7. Beautiful. So I could barely fit this problem. Can you guys see it? This says simplify. I'm going to just scoot it over a little bit because this is what we need. This work right here. So simplify the complex fraction. Complex fraction. All right. So we have 4/5 plus 1/3 over 5/6 minus 2/5. So what I would always start with, you guys, is simplify your numerator and then simplify the denominator. So what we're going to do, can I explain what I did real quick over here? Okay, can I explain what I did? Up here, you're talking about? Okay, so what we did is we divided this, and we did 7 into 69, and we asked ourselves how many 7s can fit into 69? Well, 7 times 9 gives us 63. And then we subtract it here. And 69 minus, so then we did 9 minus 3 and got a 6. And this is our remainder, you guys. So we put our remainder as the numerator, and then we divide by what we're dividing by, which is 7. And that's how we write a mixed number. Yep, Flim, I do GED tests. Just improper fraction? Yep, just taking an improper fraction to a mixed number. Okay. All right, let's go here, okay? So if you missed this one, no worries. We still have some fractions to work on, okay? So what we're going to do is we're going to get one fraction on top and one fraction on the bottom. All right, so we're going to take this over here. So we have 4/5 plus 1/3. Whenever you add fractions, we have to have the same denominator. Can somebody tell us what it is in the chat? What is our common denominator? Good. Daryl said 15. Princess, I see you. Yes. Okay, good. So 15. So we would have 15 plus 15. Now, this is the part you have to go back. 5 times what gives us 15? 3 and 3. 3 times what gives us 15? 5 and 5. Whatever you do to the bottom, you have to do to the top. That's why we're writing both of these, top and bottom. 4 times 3 is 12. 1 times 5 is 5. The denominator stays the same, and you add your numerators. 12 plus 5 gives us 17. Okay, so this is our numerator so far on this problem, okay? Now we're going to get one fraction for the denominator here. So we're going to go back. We're going to do 5, 6 minus 2/5. All right. Wonderful, you guys. I see those answers coming in. Moon, I see you. Moon said that the common denominator is 30. On it. Tiffany, yes. 30. Easy. 30. Yes, I see you guys. Beautiful. So we know it's going to be 30 here. This is a prime. So whenever you have a prime and a composite, just multiply them together to get this number. So we're going to multiply here. 36 times what gives us 30? 5. What we do to the bottom, we have to do to the top. And then this is 6, and this is 6. So 5 times 5 is 25. 2 times 6 is 12. And then we have 30. 25 minus 12 gives us, what does that give us? 5 minus 2 is 3. 2 minus 1 is 1. 13. All right, so we found one common denominator for our bottom. And so this is what it looks like, you guys. I personally would not write it like this. My brain goes like, what am I looking at when I write it like this? Right? It's like, what in the world? This is craziness, right? So how I would break this down is I'm going to change it back to like basic. So what I mean by that is I'm going to do 17 over 15. I'm going to change this division bar, this long division bar, to the old school division. And then I'm going to write the 13 and 30. Now this looking a little bit better for my brain to comprehend, because now I can do keep, change, flip. So I'm going to keep this 17 over 15 the same. I'm going to change this to multiplying, and then I'm going to flip this to 30 over 13. Any questions on this part? Good, you guys. Why did you choose to flip it? We have to flip this side whenever you're changing the, see, we can't divide fractions. So we have to change them to multiplying. And this is the process of how to divide fractions. It's called keep, change, flip. So you keep this fraction the same, you change this to multiplication, and you have to flip this side because you're changing from division to multiplication. Yeah, then you can multiply. Good. Okay, so we can't cross multiply here. We cannot cross multiply because we don't have an equal sign between. But we can cross cancel. So what I mean by that is 30 and 15 go into each other. Because if I divide this by 15, I can divide this by 15. And this will be 1. And then 30 divided by 15 is 2. So now what I would get is 17 times 2, which is 34, over 1 times 13, which is 13. Now remember, this is my improper, right? So we want to really change. Well, I mean, it does say complex fraction. I think this should be fine, but we can always just change it to a, what am I trying to say? Mixed number, 13 into 34. How many 13s can we fit? I think 2. So 2 times 13 gives us 26. And then we have a 2 here. 14 minus 6 gives us 8, I believe. So we have 2 and 8 13ths. So both of these are your correct answers. 2 and 8 13ths or 34 over 13. Good. Yes, Kristen. All right, you guys. Before we start the advance, I am slowing down. It is 10:30 for me. I just wanted to jump on because I'm trying to jump on every day for the month of, well, Monday through Friday in June. So I'm going to be jumping on every day. I don't know what time because I have 4 kids. So you know how that goes. If you're a parent, you know. So thank you so much for joining me. And hopefully I can see you guys, some of you guys or all you guys tomorrow if I can catch you. If not, have a blessed night and be safe. Bye, you guys. Thank you so much.